Hello and welcome to our today's hands-on walkthrough. My name is Ralf Turzer and I will talk about how the Adaptive AUTOSAR Diagnostics approach is easy with TargetLink. We will learn why we even need diagnostics, what the challenges are in Adaptive AUTOSAR, and how TargetLink can help you with those challenges. I also prepared a live demo to show you how modeling diagnostics can look in practice. So why do we need diagnostics in the first place? Diagnostic functionality is a key aspect in ECUs in the automotive world. It allows us to collect data over the vehicle's lifespan and provide it via standardized interfaces if necessary. The same interface can be used to read and write configuration, run procedures to help with maintenance, and even apply software updates. Those features are commonly used during debugging in the development phase or in order to support maintenance and repairs when the car is in the workshop. So far, diagnostics sound great, but there are also challenges during the development of its behavior, especially when it comes to the Adaptive AUTOSAR platform. The diagnostic functional cluster alone defines 50 special interfaces and a complex low-level API that spreads over roughly 450 pages. Additionally, there are dependencies to other functional clusters, such as the communication and persistency clusters. This means that you will have to do a lot of reading if you want to use the correct interfaces and API in your application. Also, adaptive applications are integrated during runtime. This can lead to unexpected errors and even crashes if something goes wrong within the application. All in all, and to quote my colleague, diagnostics is really a world of its own. Now, how can TargetLink help you to succeed in that world? TargetLink's model-based development approach allows you to abstract from the detailed specification of AUTOSAR. It offers to import the configuration of two diagnostic interface types that cover the most frequent use cases. The Diagnostic Data Identifier interface can be used for accessing data via read and write operations. The Diagnostic Routine interface allows you to start or stop routines and request their results. If you have a use case for another interface, please contact us and let's talk about it. You will find contact information below this video. After importing, you can reference the AUTOSAR elements from your model to generate the dedicated API calls automatically. This saves you from reading the 450 pages of specification that we talked about earlier. Finally, TargetLink enables you to simulate and validate your model and even the generated code. This helps to find errors early in the development cycle so that they are avoided during runtime after integration on the ECU. This workflow is well established among our customers worldwide and can be used in both classic and adaptive AUTOSAR scenarios, which allows for easy adaptation of your toolchain. In summary, TargetLink allows you to focus on the main thing, the implementation of the functional logic rather than satisfying APIs. Let me show you a quick example of how this looks in practice. As of release 2024b, the TargetLink Data Dictionary Manager allows you to create and specify the two new diagnostic interfaces. You can also specify a corresponding diagnostics provide port. In this example, I already imported all the specification from an RxML file. In my model, I implemented a small example of a rain sensor and wiper actuator logic. You can see that the wiper controller is implemented in parallel to the diagnostic behavior below. Please notice that the diagnostic behavior is called from external triggers in this case. I implemented one subsystem that will write the configuration of the maximum wiper speed. Another subsystem will read the lifetime of the sensor. Finally, I implemented a routine that sets the wiper position to a predefined value. Inside the subsystem, I can now reference the formerly imported elements from a function block. You can see that I specified the provide port as well as the operation of an interface. In this input block, I can reference the operation and its input argument. With this setup, you are already able to implement the logic. When looking at the outside, I implemented a scheduler that reads the sensor's lifetime every 1 second. It will set a new maximum wiper speed at 10 seconds and it will call the diagnostic routine at 15 seconds. You can now either simulate the behavior in model in the loop mode or in software in the loop mode to simulate the code. When running the simulation, you can validate the output. Looking at the simulated output values, we can now validate the logic. We can see that the sensor's lifetime is increased every second. We can also see that the Viper's maximum speed is reconfigured at 10 seconds. Finally, the diagnostic routine is called at exactly 15 seconds. Overall, the behavior is correct. Now, let me summarize what we have learned today. We now understand that diagnostics are needed to get an insight into the ECU, for example, during troubleshooting and maintenance. We saw the challenges that arise from the extensive specification of the diagnostics functional cluster in Adaptive AUTOSAR. Finally, we have learned how a model-based approach in TargetLink can help you to simplify, accelerate and validate your implementation. With that said, I want to thank you for watching this hands-on walkthrough about how Adaptive AUTOSAR diagnostics are made easy with TargetLink. If you want to know more, please have a look at our other videos and contact us directly. Have a great day.
dSPACE, your partner in simulation and validation.